Okay, so how can where is this useful? So they say we discuss the normal distribution and how to convert a normal distribution to the standard normal distribution and how to find the areas under a normal distribution curve. So here's some examples. So according to the Kaiser Family Foundation, United States workers who had employer-provided health insurance. So some employers will give health insurance and some don't. The U.S. workers paid an average premium, or this is the amount they paid per year for family coverage during 2011. Suppose that the premiums for family coverage paid this year by all such workers are normally distributed. So what they mean is, so the average premium that families paid was this amount, but not everybody paid exactly this amount. So some people paid more and some people paid less than this. Let's see if they have a picture here. So here, the average was this, and what they're saying is some people paid more, some people paid less, and the distribution of the amounts that people paid followed approximately a normal curve or a normal distribution. So the chance that someone paid out here all the way up this amount was very small. The whole distribution follows the normal curve, is what they're saying. Suppose that it follows the normal curve. So that's what they're starting with. So they say, suppose that the premiums for family coverage are normally distributed with a mean of 4129 and the standard deviation is 600. So it's not standard normal distribution, it's normal distribution with the center here and a standard deviation of this. So find the probability that such a premium paid this year was in a randomly selected worker is between this and this. So what's the probability that when we randomly select someone, that the premium that they have to pay is between here and here? So how do we do this? So we need to convert this number to the z value, or the z-score. And how do we do that? We just ask, how far is this from this? So we take the difference between these two numbers, which is 453 minus 429. And then we divide that by the size of the standard deviation, just like we did before. So we divide by 600 in this case, and that gives us 0.54. That means that this number is 0.54 standard deviations above the mean. So this number is 0.54 standard deviations above the mean. So now we can find in the table, if we look up, we can find the area to the left, all the way to the left though, but that's not what we want to know. We want to know from here just to here. So what else do we have to do? We have to convert this number to standard deviations like this, and then find the area to the left of here, and then we can find this area as the area to the left of here minus the area to the left of here. Okay, so it turns out to be this amount, and you can check the calculations here. That's one example, so let's review it once more. So according to this report, the average premium was 4129, and then they make the assumption, they say, suppose that the premiums are normally distributed with a mean of 4129 and a standard deviation of 600. If that's true, find the probability that someone paid between here and here. And we find the answer is, well, that's a different problem, sorry. That's here, 6136. Okay. Okay, here's another one. So here they're saying,